Welcome back to our topic 1 to 5 review set. We're now looking at question 2. It says to sketch the following graphs. Now, if it just says to sketch and only label the vertex, you can most definitely just use your calculator. However, because it asks you to also give the x and y intercepts, which might be in some kind of decimal form, you're going to have to find the exact values algebraically. If you're really short on time, just use your calculator, but you won't get the full marks unless you can list the x-intercepts as algebraic, exact values algebraically. So first, let's just determine the p and q value. It means we have a vertex of -2 and +3. Now, we don't need to complete the square in this case. We just have to find the x and y intercepts. So remember, if I want to find the y-intercept, at this particular point, x must be equal to 0. So let's try that first. Y is equal to 0 plus 2 squared minus 3. And that's how we solve for the y-intercept. I'm going to go ahead and graph the points that we have. And sorry, just a quick correction here. Y is a negative value, not a positive value. Okay, so let's graph this and the vertex. Okay, we have y is 0.1. And clearly for the vertex and the y-intercept to connect, this parabola must open upwards. But that's not very accurate. We don't know if the x-intercepts are at the right place. Quite approximately correct. But let's now take this equation and find out what the x-intercept actually is. And at the x-intercept, we know that y is equal to 0. And that gives us 3 is equal to x plus 2 all squared. The opposite of squaring would be to take a square root. Now we have to be careful because when we take the square root of just a number on this side, it's both positive and negative. So that means we have positive and -3 is equal to x plus 2. Inverse of adding 2 is to subtract by 2. So we're going to subtract by 2 on both sides. And that gives us x is equal to -2 plus root 3 and -2 minus root 3. Now we can plot in these points. But we don't really know what these points are. We can still approximate using your calculators, or you know that -2 minus a little bit more. So this is just a little bit greater than -2, or a little more negative than -2. This is a little bit smaller than -2. And now we are able to label our points. And here we have it. The procedure is the same for the next question, and I'll just put the solutions on here. And again, I'm just going to show the positive-negative case here for solving for the x-intercept. Once you get to this point, we want to take the positive-negative root of what's on my left-hand side. So that gives us positive-negative square root of 10 is equal to x minus 3. And the inverse of minusing 3 is adding 3. So that gives us x is equal to 3 plus root 10 and 3 minus root 10. You can put the values into your calculator to get an approximation, but make sure you're, again, labeling using exact values. Question 3 asks you to describe the actual transformations compared to the graph of y is equal to x squared. This is the parent function we're going to use, and you can review questions like this if you can go back to lesson 5.1. Again, I'm going to write down the form y is equal to a times x minus p squared plus q. And you want to remember that the graph of y is equal to x squared simply looks like this, with our vertex at 0, 0. So each one of these a, p, and q factors changes those things. The vertex is completely unaffected by the vertical stretch factor. Okay, in the future, we will look at horizontal stretch factors as well, but right now you don't have to worry about that. Your graph is only stretching vertically, and the vertex stays at p and q. There is a sequence you always want to describe the vertical stretch, vertical stretch factors and reflections first, and then apply your horizontal and vertical translations. But the stretch and the reflect can interchange in sequence, and it will not affect your final outcome. Okay, so let's look at the first one. Our stretch factor is 1/3, meaning every original y value will be multiplied by 1/3. Next, we have a horizontal stretch factor or horizontal translation of p, and p here is just a +5. And a positive indicates a move towards the right horizontally. Finally, we have our q value of +6, and that is a vertical translation by 6 units up. The next question here has a reflection on x-axis because it starts off with a negative value. Again, I am writing this in a sequence, so you can write that down as step 1, 2, and 3. So the first step here, we are reflecting. But you can also stretch first, although I'm going to write my stretch as step 2. And finally, your horizontal and vertical translation. Doesn't matter which one of these comes first. Please note that your horizontal translation is 2 units left this time because you have x + 2, which means p value must have been a -2. Question 4. This type of question asks you to write out the vertex form, and you are given the vertex point and some other point. This point could be your x-intercept, a y-intercept, or it could be just a random point on the function. We start off by writing out our equation with the x and y values of the vertex given. So note that your x value is -2, so that means we have x minus -2, which is why I have now written it as x + 2. Next, we are going to substitute the x and y values for the given point here, -4, -4. And that leaves us with only the value a to be solved. Once you're able to solve for a, you can plug that back into your equation with the vertex point, and you'll have your final vertex form. There we go. So we have the vertex form. Next part of the question asks you to state x-intercepts and y-intercepts. Let's start with the x-intercept because this one's the one that's a little bit tricky since you've got 2 x-intercepts to find. First, we make y equal to 0. And we'll continue solving for the equation until we are able to isolate x. Okay, so now we get to a point where we have x + 2 all squared. I want to get rid of the square here, so the opposite of squaring is taking a positive and negative root. So now I have -2 afterwards. -2, positive and negative square root of 2 is equal to x. This means x must be equal to these 2 separate points. Okay, and now we're done here. Last but not least, let's solve for the y-intercept, recalling that at the y-intercept, x is equal to 0. So we solve for y in the equation, but the only thing is we replace x with 0. And y is equal to -4. So that means we have the coordinates 0, -4 for the y-intercept. That's it for this question. I will put the solutions to the next question up. All right, let me know if you have any questions about the question 2 to question 4 here. Question 5 and 6 will be in the next video.